Hi, in this series we're looking at creating geometrical shapes using custom meshes in Unity. In the last episode we focused on creating the regular convex polygons using custom meshes, and in this episode we're going to extend that by adding UV mapping to them. Let's get started. We're going to continue to use the pentagon to demonstrate our process. The same code will work with all our regular polygons. We need to map UV coordinates to each of the vertices, so that Unity knows how to fit the rectangular textures to our custom mesh shapes. Currently, we're using the formula r sine theta cos theta to define our points, where r is the radius. Before we go any further, let's talk about how UV mapping works. A texture is your image file that contains the graphics you wish to apply. In this example, I'm going to use this checkerboard pattern. For technical reasons, you should ensure your textures have a width and height that is a power of 2. For example, 128 by 128 or 256 by 256. The texture does not have to be square, so 256 by 128 would be fine. However, for simplicity, I'm going to keep my textures square. What we are aiming to achieve is to take this texture and apply it to our pentagon, like so. The texture that will appear will be interpolated between the vertices, effectively masking off just the bit we want, giving us something that looks like this. However, things aren't quite so simple for us. Let's bring back the texture on the left. The UV coordinates are given as a percentage of the texture, represented as a number between 0 and 1. This means we cannot use our coordinates of our vertices for our UV because the pentagon is centered around the origin and the UV isn't. Let's set our pentagon's radius to 1 in the visualization. So our pentagon coordinates are going from -1 to 1. Our UV coordinates are from 0 to 1. So let's move our UV texture to show where it fits on the plane. From the visualization, you can see that our pentagon is twice as large as it needs to be, so it'll need scaling down. We will also need to move it over. In fact, we've made the key observation there. For regular polygons, if the radius of 1 is twice as big as we need for the UV mapping, then we need a radius of 1/2. So let's lock in that value in our formula. Now we've got the right scale on our vertices, we just need to locate them in the right position. Currently the pentagon is centered at 0, 0. To center it in the unit square for the UV mapping, we wish to center it at x equals 1/2, y equals 1/2. So let's add that into our equation for the vertices. As we have the outer multiplier of 1/2, we're going to need to multiply our offset by 2. So we need to add a 1 in there. So when that's multiplied by the 1/2, we get the 1/2 as required. This moves the pentagon to the right location. Right, that's it. We've got our formula for the UV coordinates, so let's add that into the code. Here is the full code from the last episode. As we've discovered, we create the UV coordinates in a similar manner to the vertices, so we're going to add the code into the same for loop. We need a new vector2 array large enough to hold the UV mapping for each vertex. To create the UV coordinates, we just need to plug in the function we've defined on the right there. 1 plus sine theta for the x coordinate, and 1 plus cos theta for the y coordinate. As with the vertices, each iteration round the for loop gives us the angle for the next vertex. All that remains is to scale the vector2 by 1/2 so it's the right size. The final thing is to attach the UV to the mesh and we're done. It's as simple as that. We've only had to add 3 lines into our old code. Now in practice, you may not have a single large texture for each element. You can have a texture sheet with multiple items on it, like this. In this situation, you don't want the UVs to go from 0 to 1, but rather the section of the texture you're interested in. So in this example here, to retain the checkerboard, we would need x going from 1/2 to 1 and y going from 1/2 to 1 also. So in this case, we need to increase the offset by 1/4 in each direction and scale the vertices down by 1/2 again. This gets us back to what we want. The mathematician in me insists that I tidy up the formula, and there we have it. You have all the knowledge you need to modify this for whatever sort of texture sheet you're using, as often it won't be as simple as this. As ever, the full code is linked in the description below, and I hope you found this information useful in some way. See you next time.